What if cosmic redshift is not proof that galaxies are racing away, but simply what you see when today's fast rhythm looks back at the universe's slower past? In the energy filament theory, redshift is first a record of how the cosmic beat has changed, not an automatic label for recession speed. And once you separate those two ideas, a lot of obvious conclusions stop being so obvious. Textbooks tell you a simple story. The farther a galaxy is, the redder its light. Just like a train horn sounds lower as it moves away, so the galaxy must be receding and the universe must be expanding. The first part is fine. If something moves away, its light will be redshifted. The jump is in the second part. Seeing red light does not guarantee motion away. Just as hearing a low sound might mean the drum is being hit more slowly, not that the drummer is running backwards. The real question is not, did the light turn red, but why is this light set to a slower beat than ours? The answer here is very plain. In the past, the cosmic energy sea was tighter. Particle rhythms were slower, so the light they emitted was born redder. You have to remember the deeper rule from earlier. Time is not an abstract axis. It is the internal beat of particles. The tighter the sea, the harder each cycle is to complete, so the beat slows. The looser the sea, the easier cycles become, so the beating speeds up. The very early universe is pictured as an extremely dense, ultra-high-tension energy mush, where particle rhythms are heavily suppressed. Light emitted from that state naturally has lower frequency and longer wavelength, so it is red from birth, not made red later by some cosmic stretching. As the universe cools, tension drops and the energy sea relaxes. Those internal rhythms speed up and emission frequencies climb. We live now in a high-tempo era. That means when we, with our fast-ticking atoms and clocks, looking back at light set by slower beats, we inevitably see it as redshifted. It is like replaying a 24 frame per second old movie on a 120 Hz screen. Every movement looks slow and every sound feels deeper, not because the film slowed down, but because your current hardware runs much faster. Or think of two drums. A loose drum gives a deep, low thump and a tight drum gives a bright, high tone. If you record both and compare, the loose ones will always sound lower, even if neither drum moves an inch. The early universe is the loose drum. Today's universe is the tight one, and redshift is just what you get when you mix their beats. So when you see very distant galaxies whose light is strongly redshifted, you can interpret it as they are fleeing at huge speeds. But you can also interpret it as we are watching a slow tempo recording using fast tempo eyes. Does that rule out expansion? No. Space may be expanding, or not. But redshift alone cannot prove it. What redshift does prove is that earlier emissions was tied to slower internal rhythms and later emissions to faster ones. It does not, by itself, prove that distances have stretched between then and now. Once you see redshift as tempo history instead of automatically as velocity, 4 key features of the data fall into place. First, the fact that farther galaxies are more redshifted fits naturally. Farther means earlier in time, and earlier means slower beats, so farther is redder becomes older is slower. Second, the smooth, continuous distribution of redshift values matches a universe where the energy sea cools gradually. Particle tempos speed up gradually and emission frequencies climb gradually, so redshift changes smoothly without needing a precisely tuned expansion speed curve. Third, the lack of any preferred direction in redshift. The sky looks statistically similar in every direction is exactly what you expect if the main driver is how far back in time you look, rather than motion along some special spatial axis. Fourth, those too far, too fast galaxies that seem to demand exotic expansion histories are seen as cases where a large difference in beatings has been misread as an extreme velocity. Put together, this makes one crucial conclusion feel natural. Cosmic redshift is primarily the visible skin of the universe's rhythm history, not the unique smoking gun that space must be stretching. There is more than one logically consistent way to read the same redshift data, and for a long time we have mainly followed just one of them. Seen through this lens, Cosmic redshift is less like watching galaxies desperately escape and more like watching an old slow tempo recording through a very fast player. It tells you the beat has changed, but it does not, on its own, prove that the stage itself has grown bigger. Tap follow, share it on New Physics, Clear Universe.